Ever pondered the mystery of strings in the universe? There's an intriguing concept in physics that might just tickle your fancy. The Nambu Goto action. Picture a string, infinitely thin, moving through the fabric of space and time. It dances, it twirls, it traces a path. This path, or more accurately, the area of the sheet traced by this string, is at the heart of the Nambu Goto action. Now, let's dial back a bit to understand this better. You might be familiar with Lagrangian mechanics, an approach to physics that focuses on the action of a system. The action is a special quantity that an object, under the influence of external forces, seeks to extremize. This means the physical path taken by the object is such that any small variation from it doesn't significantly change the action. In simple terms, think of a ball rolling down a hill. The path it takes is the one where the action, a value derived from its kinetic and potential energy, is minimized. Now, apply this concept to a relativistic particle, one that might be zipping close to the speed of light. The action for such a particle should be a Lorentz scalar, a quantity that remains the same for all observers, regardless of their speed or direction. This is where the proper time comes in, the time measured by a clock moving with the particle. But what if our particle isn't a mere point, but a string? A string, unlike a point, traces out a two-dimensional sheet as it moves through space-time. This is called a world sheet. The Nambu Goto action, named after the brilliant physicists Yoichiro Nambu and Tetsuo Goto, is the simplest invariant action in bosonic string theory. It's all about the behavior of these zero-thickness strings. So to sum it all up, the Nambu Goto action is a concept in physics that describes how an infinitely thin string moves through space and time. It's based on the principles of Lagrangian mechanics, focusing on the action of the string, which is proportional to the area of the world sheet traced by the string. This action is extremized, meaning it's either minimized or maximized, based on the path the string takes. This fascinating concept is a cornerstone of string theory and offers a unique perspective on the intricate dance of the universe. The Nambu Goto action truly takes us on a journey, from the simplest of strings to the grandeur of space-time.